Amdahl's law showed us the effect of contention on a distributed system. It demonstrated that when we have contention, as we try to add concurrency or as we try to scale up, we start to see diminishing returns. There is another effect that we have to take into account, and that is the effect of coherency delay. So what is coherency delay? Well, in a distributed system, when you're trying to synchronize the state across multiple nodes, we do that using crosstalk or gossip. Essentially, what we have here is we have a system of multiple nodes, and they want to reach a state of coherence where they all agree on the state of the system. Now, in order to reach that state of coherence, each node in the system will have to send messages to each other node, informing them of any state changes. Over time, all of the nodes in the system will receive all of the messages notifying them of the state changes, and they will reach that state of coherence. But this does take time, and the time that it takes to reach this synchronization is what we call coherency delay. If we increase the number of nodes in the system, it's going to take longer for the messages to flow through, and as a result, we will increase the coherency delay. A good way to look at this is if you think about it in terms of a meeting. If you have a meeting with one person who's trying to make a decision, that's very easy. It's very fast for one person to make a decision. On the other hand, if that meeting has 20 people in it, that's going to be much slower. Everybody's going to have to talk to everybody else. They're going to have to resolve any disagreements, and eventually they are going to reach a decision. But it takes longer for 20 people to make a decision than it takes for one person to make a decision. So that's very clear. And that brings us to Gunther's universal scalability law. So Gunther's universal scalability law builds on top of Amdahl's law. Amdahl's law, remember, showed us the effect of contention on a distributed system. It showed us that we get diminishing returns. Now, Gunther's law takes into account the effect of contention, but it also accounts for coherency delay. And what Gunther's law found was that when we factor in coherency delay, not only do we get diminishing returns, we actually start to get negative returns. And essentially what happens is, as we begin to scale up the system, the cost to coordinate between nodes can eventually exceed any benefits. As we scale up the system, we have to have more and more communication between all those nodes, more and more coordination with all of those nodes. And as a result, we eventually reach a point where the cost of that communication and coordination exceeds any benefits that we got from scaling up. So this is a problem when we're building distributed systems, and it's something that we have to take into account. Remember, we want to try to get as close to our linear scalability line as possible. We understand that that's a fantasy and we're probably not going to get there, but we want to try to get as close as possible. And in order to do that, we have to factor in things like Gunther's universal scalability law.